Hello, this is the recording of our live lesson scheduled for today, the 23rd. It says the 20th, it was originally planned on Tuesday, but we are doing this on today. So I wanted to go over our last strategy for solving systems of equations. Next week, we're going to start talking about exponent rules, and then you should start seeing your assessments assigned within ALEKS starting next week, depending on where you are in your topic mastery. And so the first thing for our warm-up, I wanted to go over how just to graph one line. Because our strategy today is to find a solution by graphing two lines. And so in order to do that, I want to practice first by graphing one line. So here we see the equation y equals negative 3/4 x plus 1. A more general version of a line is y equals mx plus c, or you might see this as b, depending on the resource. Either way, the m is the slope, which is your rise over your run. Rise is your change in your y, and run is your change in your x value. And then the c value is the y-intercept, and it's exactly what it sounds like. The y-intercept is where the line crosses the y-axis, so where it intercepts the y-axis. And so if I look at the equation, starting with the c value, it says plus 1. That means I have a point on the y-axis at that value, plus 1. And so at positive 1, my line crosses the y-axis. Now I need another point to draw my line. So I'm going to use this slope. The slope in this particular case is negative 3/4. So the negative 3 correlates with my change in y. And the 4 correlates with my change in x. And so since it's a negative, that's my rise or my change in y. So I'm going to go down 3 because it's negative. 1, 2, 3. And then over 4. 1, 2, 3, 4. And I'm going to plot my point. And once you have at least 2 points, you can graph your line. And oh, I'm sorry. I thought I had the line. I'm gonna do my best to sketch it. Sketch it here. Have a little trouble sketching online, but yeah, I'm having trouble. Sorry. Let's see if I can get a little bit better with the tool. So in order to sketch your graph, you're going to want to connect your 2 points. There we go. Oh, and so we have something like that. There we go. And so that would be my line. Another strategy that you could use is making a table. And so I could do an input-output table. Instead of what I did here, which was plot the y-intercept first, the 1, and then use the slope, I can do input-output table and find coordinate pairs. And so if I choose 3 points, for example, if I start by plugging in negative 4 into the rule right here, I would get negative 3/4 times negative 4. I'm going to make it a fraction plus 1. The reason I chose negative 4 is because then I can reduce the fraction to 1. So I get a positive 3 plus 1, which is just 4. So my first point is negative 4, positive 4, negative 4, positive 4, right there. So we can see that would be a point on the line if I extended my line. And then if I plug in 0, I get -3/4 times 0 plus 1. Well, anything times 0 is 0, so that's why there's a point at 0, 1 right here. And then if I do the same thing with +4, I'm going to get this fraction here, which is -3 plus 1, which gives me -2. And then that actually matches this point right here that we plotted. So you can make a table of values and then plot your points that way. Or if you liked my first strategy using the intercept and the slope, that might be a little bit quicker for you. I do have additional videos on how to graph lines within the course site as well. So if you want more examples, look there and you should see more videos on how to graph lines. So our learning objective is to solve simultaneous equations using graphing today. And this works really well for certain problems, especially when you notice the equation is pretty simple. Then it should be pretty simple to graph. And then you actually see the answer, because the answer is where the two lines where they have a common x and y value, and so it's going to be an actual point where the lines cross. And so there are 4 steps. Step 1 is to put equations in slope-intercept form. So they want to be y equals mx plus b form. And so if it's in standard form, then you want to move it around. So like if you have, like with elimination, we had x and y on the same side. And so we moved things if we needed to. Same thing, if it's not on the same side, then you want to move it so that it is y equals mx plus b form. Next, you want to graph both equations on the same coordinate plane. And so basically what we did with our warm-up, you're going to do that twice. So you're going to have 2 different lines to graph, and you're going to plot them carefully. And you want to make sure it says use a ruler and graph paper. So that's if you're doing this by hand. Within ALEKS, you're going to have the tools to accurately graph and plot your points. They're going to connect the points nice and straight, so you won't have to worry about what I was struggling with earlier to connect the points digitally, but you want to make sure that you are taking your time and clicking the correct points on the coordinate plane. Step 3 is to find where these graphs intersect. So if you draw your lines accurately, you should be able to accurately determine where they intersect. And that's your solution. And so your solution should be an ordered pair, an x and a y coordinate. And step 4, just like the other strategies, you're basically done at step 3 once you have your ordered pair. But step 4 is to use substitution, plug back in, make sure that the point you found actually works. If you need to, pause the video right now in order to write down these steps. And then on the next slide, you'll see these steps in action. So pause the video now if you need to write these down, and then when you're ready, press play for the example. So here's example 1. Solve the simultaneous equations y equals 2x minus 2 and y equals x plus 1. So I'm going to show the strategy of using a table of values, but you can also use the first strategy I showed using the slope and the intercept. Should be pretty easy for this first graph. And so we have y equals 2x minus 2. So if I do my input and output table, for x equals 0, I'm going to get 2 times 0 minus 2, which is equal to -2. For 1, I'm going to get 2 times 1 minus 2. 2 times 1 is 2, minus 2 is 0. And then if I plug in 2, I'm going to get 2 times 2 minus 2, lots of 2's there. So I get 4 minus 2, which is 2. So that should match what you see here. And there's those 3 points plotted. So there's 0, 2, 1, 0, and 2, 2. So there's those 3 points plotted. And I'm going to go ahead and let the digital tool plot it, the graph. And now I'm going to go ahead and do the same thing for the second graph. So this rule is x plus 1. And so that actually could be done in your head pretty easily, but I'll go ahead and write it out. 0 plus 1 is 1. 1 plus 1 is 2. And then 2 plus 1 is 3. So there's my 3 values for my table. And then now I have my ordered pairs. So I have the point 0, 1, 1, 2, and 2, 3 to plot. There they are. And now I'm going to continue my line. And this is why it's really important to accurately plot your points, because once you plot your points, you're going to see hopefully a nice spot where they intersect. So there's the spot there. And so we can see that the lines intersect at the point 3, 4. And so if I give myself some space, there we go. So my answer would be 3, 4. But it's always good to check. So this right here is 3, 4. So depending on the tool, Alex might have you answer it as x equals 3 and y equals 4. Or it could be as an ordered pair. But once we have our answer, we want to just double check that it makes both of these equations true or equal the same thing. And so I want to know if 3 and 4 will work. And so with my first equation, y equals 2x minus 2, I'm going to plug in these values. So does 4 equal 2 times 3 minus 2? Hopefully you can do that pretty quickly. Let's just write it out. 2 times 3 is 6 minus 2. And last time I checked, 6 minus 2 is 4, so that's a true statement. And then we check the second one, y equals x plus 1. So does 4 equal 3 plus 1? Yes, I don't have to do any extra work. I know that's true as well. So once you check that these numbers right here make both of your equations true, you know you have your answer. Here is one directly off of Alex, and so this is one that you would see, and so I will go ahead and go through it. First of all, this top equation is not in slope-intercept form. It says negative 2 plus y equals 7. So the first thing I'm going to do is I'm going to rewrite this by adding 2x to both sides. So now I have y equals, and then this is a positive 2x and a 7. They're not like terms, so they have to stay separate. So I get a positive 2x and then plus 7. And then the other equation's fine. Y equals negative 1/4 x minus 2. So now what I'm going to do is I'm going to make a table of values for each one of these. Let's do the first one. Okay, so I want to choose values that will fit on here. Because there's no fraction involved, I'm not going to limit it too much, so I'm going to go ahead and choose 0, which would give me 2 times 0 plus 7. And actually, that's not on my graph, so I'm going to pick 1 next. I'm going to try negative 1 because that gives me 2 times negative 1 plus 7. So this is negative 2 plus 7, which is 5. So this one I can plot. Negative 1, 5. And I'm going to choose negative 2 next. So 2 times negative 2 plus 7. 2 times negative 2 is negative 4 plus 7 is 3. So we get to 3. There we go. Negative 3, we'll do that as well. So that's negative 6 plus 7, which is 1. You should be able to start seeing a pattern. This goes down to there. So there's the graph of the first line. And again, I'm going to do my best to connect these. It is a little bit hard. Or I'll use the line actually. Here we go. There we go. Okay, so now we'll go ahead and plot the other graph. Let's do that in a different color. So we have x, and then we have y equals negative 1/4 x minus 2. I'm actually going to start with, kind of like with my warm-up question, I'm going to start with negative 4. The reason is, and then maybe I'll do 0 and positive 4. The reason is if I use a 4, then if I multiply by the 1/4, the denominator is going to cancel out. So if I have negative 1/4 times negative 4 over 1, and then minus 2. This right here is kind of complicated looking, but really the 4's will reduce, and so we get negative 1 times negative 1, which is positive 1, and then positive 1 minus 2, which is negative 1. So my point is negative 4, negative 1. Negative 4, hey, okay, so that actually is our answer. Let's continue real quick. Negative 1/4 times 0 minus 2. This becomes 0. So my intercept is 0, negative 2. Right there. And so we will plot that graph. But based on even my coordinate points here, negative 4, 1. And if I plugged in negative 4, 1 here, that's also on my first graph. So that's my answer. And so I'm going to go ahead and give some space right here. And show you the worked out solution here. So negative 4, negative 1. Oh, I think I forgot the negative sign. Sorry about that. Negative 4, negative 1 is the solution. And how I know, I checked. So if I left it as a positive 1, I would have, when I checked, I would have figured out that that is incorrect. So if I check, then I should get true statements. So is y equals 2x plus 7. Does negative 1, negative 4 work for that? So is negative 1 equal to 2 times negative 4 plus 7? Well, 2 times negative 4 is negative 8. And if you add 7 to that, that does equal negative 1. And then for the second equation, does negative 1 equal negative 1/4 times negative 4 minus 2. And the answer is yes, because this right here just becomes positive 1, and 1 minus 2 is negative 1. So that is also true. So x equals negative 4 and y equals negative 1. That is the correct solution. Now for this week, hopefully you've been working on your hours because of missing school for the holiday on Monday and testing. Your hours is 3. So if you've hit 3 hours, then you will get your full credit. I don't think anyone was actually assigned the assessment this week. I want to start that next week, so don't worry about that. So your assignment due by Sunday, 3 hours, and then 18 topics to get your full 20 points for the week. If you have any questions, make sure you text me or email me. And then also know that for this topic, there are more videos within the course site. So if this was not quite enough examples, look there or email me questions if you want to see more examples. I'd be happy to send more videos out. Have a nice day, and I'll see you guys next week.